lecture 9. My name is Jorge and this is for college algebra, and this is piecewise-defined functions. So there are two objectives in this lecture. The first one is we're going to go ahead and graph the functions that are listed in the library of functions. And some of these functions you've already seen and are familiar with. And then the next thing is the piecewise-defined functions, and that's going to be towards the end of this video. So the first function that we're going to be talking about is what we call the square root function. So there are 5 different things that we're going to talk about. The first thing is that the domain and the range are the set of all non-negative real numbers. So so we can essentially use any input or output here as long as is a positive real number. The second thing is that the x-intercept of the graph is f of x is equal to square root of x is 0, and the y-intercept is also 0. And you can see on the graph that the only intercept is actually the origin. Now the function is neither even nor odd. That means it's not symmetric with respect to the origin or the y-axis. Now the function is increasing on the interval. And so I want you to think about what does that mean. And so just quickly to review, that means that if I choose the points x1 as 1 and x2 as 4, then f of x2 will be greater than f of x1. So in this case, you can see that 1 is less than 4, but f of 4 is greater than f of 1, and that means that it is a increasing function. And also the function has an absolute minimum of 0 when x equals 0. So the next function is the cube root function. Again, the domain and range is the set of all real numbers. The x-intercept of the graph is 0, and the y-intercept of the graph is also 0. Now the graph is symmetric with respect to the origin, so that means that the function is odd. And again, the function is increasing on the interval from negative infinity to infinity, and the function does not have any local minima or local maxima. So here's the graph of this function, and you can see that the only intercept is the origin, and it is increasing because we can choose any 2 points, and the result of any 2 points, as long as x1 is less than x2, will be that f of x2 is greater than f of x1, so therefore the function is increasing on the interval. So let's talk about graphing the cube root function. So the first thing is we're going to determine whether it's even, odd, or neither. And then we're going to state whether the graph is of f is symmetric with respect to the y-axis or with respect to the origin. Then we're going to determine the intercepts of any, and then we're going to go ahead and graph the cube root function. So the first thing is that we see that the function is actually odd. So since it's odd, it's symmetric with respect to the origin. So f of negative x is equal to negative f of x. The next thing is that f of 0 equals 0, which means that the x and y intercepts are both 0. And here we have a table, and then here we have the graph. So we've seen the graph before, but this is how you would essentially graph any function. Now let's talk about the absolute value function. So we're going to determine whether f of x equals the absolute value of x is even, odd, or neither. We're going to state whether the graph of f is symmetric with respect to the y-axis or the origin. Now, whether it's symmetric with respect to the y-axis or the origin depends on whether it's even or odd or neither. Then we're going to determine the intercepts of any, and then we're going to go ahead and graph the function. So the first thing is that we see that f of negative x is equal to f of x. So that means that the function is even and symmetric with respect to the y-axis. The next thing is f of 0 equals 0. So x and y intercepts are both 0. That means it's at the origin, and here's just a table with 4 values, 4 ordered pairs. And then here is the graph of this function. So several other things. So the domain is a set of all real numbers, and the range of f is as long as y is greater than or equal to 0. And you can see that by the graph because the lowest value is 0, 0. The x and y intercept are both 0. The graph is symmetric with respect to the y-axis. It's an even function. And the function is decreasing on the interval of negative infinity to 0. So it's decreasing from negative infinity all the way to 0. And you can see here that f of, negative 3 is less than negative 2, but f of negative 3 is greater than f of 2. So that means that it's decreasing. Now, if we go to the other side, or the first quadrant, again, we can choose the points 2 and 3. So 2 is less than 3, but f of 3 is greater than f of 2. So that it's increasing on the quadrant 1, and it's decreasing in quadrant 2. So, and then it has an absolute minimum of 0 at x equals 0. The next function is the constant function, f of x equals b, where b is a real number. You also know this as y equals b, where it's just the graph of the equation. So the intercept for this particular function is just at 0b, whatever b is. The next one is the identity function, f of x equals x, or y equals x. And here it just means that whatever the value of x is, the corresponding value of y is the same. The square root function, also the parabola, f of x equals x squared. For this particular function, the minimum occurs at the origin, 0, 0. It's also known as the vertex. And then the next one is the cube function. So f of x equals x to the third power. The next one is the square root function. We talked about this one earlier. And then the cube root function. So f of x equals the cube root of x. And then what is known as the reciprocal function, f of x equals 1 over x. And here you can see that the graph of this one is slightly different than the ones that we've seen before. Anytime you have a function that is that's a fraction, you tend to have a graph that's similar to the one that you see now. F of x equals the absolute value of x. Now the next function is the greatest integer function. So f of x equals the greatest integer of x, and then this means that it's the greatest integer that's less than or equal to x. So here's the table. So when x is -1, the greatest integer that's less than or equal to x is -1. When x is -1/2, we actually go to -1. When x is -1/4, we go to -1, because -1 is the greatest integer that's less than or equal to the x. Then when it's 0, of course, it's 0. 1/4 is 0. 1/2 is 0, and so on. So, and this is what it looks like. And you might have seen this before, and this is a step function. Some people call it a step function. And so you can see how we graph this function. So it's not a continuous function because it does have gaps. So this leads into the discussion about piecewise-defined functions. So here we have a piecewise-defined function. So this function f of x is equal to, and we have 3 components to this particular function. So the first one is -x plus 1. And we use this part of this function if x is between -1, less than or equal to x, or less than 1. Now if x equals 2, if x equals 1, then we just use the constant function f of x equals 2. Now, if x is greater than 1, then we use the function f of x equals x squared. So it's defined depending on the value of x. We use different parts or different functions. So we're going to go ahead and find f of 0, f of 1, and f of 2. We're going to determine the domain of this particular function. We're going to go ahead and graph the function. And then we're going to find the range of the function. So the first thing is that f of 0 is equal to 1, since the parameters are, as if x is between greater than or equal to -1 or less than -1, then we use the -x plus 1. F of 1 equals 2, and you can see the restrictions that we have there. When x equals 1, the function is just going to be equal to 2. And then the other one is if x is greater than 1, then we're going to use x squared. So f of 2 is 2 squared, which is 4. The domain of this function is from -1 to infinity because it's only defined up to -1. And here's the graph of the function. So as you can see, when x is between -1 and 1, we actually use this linear function, which is -x plus 1. So this is what this line is right here. Now, when x equals 2, we just have the ordered pair, and we just plot that one there. Now, less than 1, that means that this part here is defined all the way up to but not equal to 1, and that's why you have this hole right there, or this open circle. And then this one is when x is greater than 1, so again, that's why you have an open circle. So you have 2 open circles here, but then it's only defined for 1 as being equal to 2. And then of course, from 1 to infinity, we actually graph the function y equals x squared. The range is from 0 to infinity. And you can see that the only y values are from 0 all the way up to infinity. So here's an example. In the summer of 2009, Duke Energy supplied electricity to residents of Ohio for a monthly customer charge of $4.50 plus 4.234 cents per kilowatt hour for the first 1,000 kilowatt hours supplied in a month, and then 5.3622 cents per kilowatt hours for all the usage that's over 1,000 kilowatt hours in a month. So what is the charge for using 300 kilowatt hours? What is the charge for using 1500 kilowatt hours in a month? And if C is the monthly charge for X being the kilowatt hours, let's develop a model relating the monthly charge in kilowatt hours used that is express C as a function of X. And we'll go ahead and do those three parts. So the first one is, since we use the 300, it's just going to be 450 plus the 4.2345 cents times 300, and that charge will be $17.20. And if you think about it, this is a piecewise defined function, right? So we use one function when we use an X amount of kilowatt hours, and we'll use another one if we exceed that amount of kilowatt hours. Now B is going to be 4.50 plus the 4.2345 cents per kilowatt hour times 1,000, and then the 5.3622 cents for the next 500 kilowatt hours, and that's going to give us $73.66. So for the first 1,000, you charge it at 4.2345 cents, and in the next 500 hours, you charge it at 5.3622 cents. And then let's go ahead and look at C. So we're going to let X represent the number of kilowatt hours used. Now, if the kilowatt hours is between 0 and 1,000, then the monthly charge C can only just be found by multiplying X times the 4.2345 cents and then adding the monthly customer charge. So then if you use between 0 and less than or equal to 1,000 kilowatt hours, then the function that you're going to use is C of X, which is right there. Now, for X is greater than 1,000, then the charge is going to be the charge for the 1,000 kilowatt hours plus the monthly customer charge plus the number of kilowatt hours greater than 1,000. And this is why in this part over here, X minus 1,000, because the first 1,000 you charge it at 4.2345 cents per kilowatt hour. But so you have to find a difference of what you actually use minus the 1,000, because you're only going to charge the difference or what's above 1,000 at the 5.3662. So therefore the actual function then for anything over the 1,000 would be the 5.3622 times X excuse me, minus the 6.777. And you can see how we worked out the the algebra there, excuse me. And that's the end of lecture 9, part 1. Thank you.